So this section will look at the majority of concepts in 11.3 with short-run behavior polynomials. So the last section looked at long-run behavior, which was really what the function did at the far ends. Did it go to infinity, did it go to a negative infinity, and that's really determined by that leading term. The short-run behavior is going to be what happens to the function in between the ends. How many turns does it have? How many, what zeros does it have? You know, that kind of thing. So we'll look at finding some possible polynomial functions with properties. Then we'll look at finding some possible functions with just the graph. And there's a few things to keep in mind. If you can write it with linear factors, you know, there's some constant and then x minus r, x minus s, or x minus whatever, then you can see the zeros. You can find that constant using usually some kind of xy point, whether it's a point on the graph or maybe it's the y-intercept, but they'll give you a point so that you can find that constant that'll drive the shape. The other thing to keep in mind is that if it's an nth degree polynomial, it will have at most n minus 1 turns or bumps. So for example, if it's a fourth degree that you know ends up or down, then at most it'll have 3 turns. And that's at most. It could have no turns, it could have 1 turn, it could have 2 turns, but at most 1, 2, 3 turns. Or again, it could just have 2 turns depending on, it's actually 3. So it could come down and just have 1 turn, but it'll depend on the zeros, it'll depend on the y-intercept and the other behavior. But it'll have at most n minus 1 bumps or turns. So for the first one, we'll look to find a function where f is has a degree that's less than or equal to 2. So it could be degree of 0, which is a constant, degree of 1, which is a line, degree of 2, which is a quadratic. You're also told that f of 0 equals f of 2, and that equals 0. And you're also told that f of 3 equals 3. Okay, remember from previous information, f of 0 equaling 0 gives you the point 0, 0. F of 2 equaling 0 is the point 2, 0. Those are your x-intercepts, or your zeros. The f of 3 equals 3 gives you the point 3, 3 that we'll use to help us find our constant in our polynomial function. So if we already know the zeros, and we know it either has to be degree of 0, which will make it a constant, degree of 1, which will be a line, or it could have degree of 2, which will be a quadratic. And the fact that it has 2 zeros, it's going to be the quadratic. So if we put that into our factored form, we get x, you could put x minus 0 if you want, but it's just a single x. X minus 2. So that's a constant times x minus 2. And then we'll use, oh no, there we go. We'll use the point 3, 3, plug it in for x and y, all the x's, all the y's, accordingly. And we'll get 3 equals a times 3 minus 2. So that's 3 times 1. So a times 3, so a is 1. Which you don't really have to write because it's a 1. So our function, our possible polynomial with that information is x times x minus 2, or if you wanted to expand it, it would be x squared minus 2x. That function would have the properties of zeros at 0 and 2 going through the point 3, 3, and it would have the right shape that we needed it to have a degree that's less than or equal to 2. Okay. Um, here's another one. Let's say that the function is a third degree polynomial. You're also told that f of negative 3 equals 0, f of 1 equals 0, f of 4 equals 0, and also that f of 2 equals 5. All right, so the fact that it's third degree means it could have at most 3 solutions, 3 zeros, and you're given that. You're given that negative 3, 1, and 4 are zeros. So we can take those and plug the given zeros into factored form, keeping in mind that we have to keep some kind of constant out front. So y equals, or if you'd like to do f of x equals, it's the same thing. Some constant with x. So if negative 3 is the 0, I have to do plus 3 in my factored form. And if 1 is the 0, I have to do x minus 1, and then I have a 0 of 4, so I'll do x minus 4. Okay, so then the next thing will be to come up with this constant. So given that f of 2 equals 5, I plug 2 in for x, 5 in for y, and I get 5 equals k times 2 plus 3 times 2 minus 1 times 2 minus 4. I clean that up, I get 5 times 1 times negative 2. Keep going, you get that that's negative 10, and you get that your constant is negative 1/2. So this is actually going to be a third degree polynomial with a negative coefficient. So its shape will look something not that direction. Eraser. Here we go. It'll look more like that guy. But the formula is negative 1/2 x plus 3 times x minus 1 times x minus 4. And you do not have to expand that out. You're welcome to leave it in factored form, reflecting the fact that those are the zeros. All right. Let's do maybe one more. Let's take the function g is a fourth degree polynomial, so it has at most 4 distinct zeros. You're also told that g has a double zero at x equals 3. Also told that g of 5 equals 0, g of negative 1 equals 0, and g of 0 equals 3. All right, so we're told fourth degree. The double zero at 3 will get counted twice in a factor. G of 5 equals 0, that's a 0. G of negative 1 equals 0, also a 0. So you have your 4. 3 gets counted twice, 5, and negative 1. The g of 0 equals 3 is the y-intercept, but it's also just another xy point that we'll use to find our constant. So if I use constant times, okay, so my double zero at 3, if I have a 0 of 3, I have to do x minus 3. So you can either write it twice, or you can write the quantity squared. Either way, it's the same function. It's just a lot of times you'll see the quantity squared if it's a double zero. The 0 at 5, I'll do x minus 5 in my factored form, and then my 0 of negative 1, I'll have to do x plus 1. Okay, so using that factored form, and then going back and pulling this other point, which happened to be the x-intercept that I was given, I'm going to plug in 0 for all the x's, 3 for the y, and I get 3 equals k times 0 minus 3 squared times 0 minus 5 times 0 plus 1. I get that that's 9 times negative 5 times 1. That's negative 45. Which if I divide both sides by 45, I get a constant of negative 1/15, which needs to stay 1/15. Do not give a decimal for it. So my possible fourth degree polynomial, which is actually a g function, so I'll put g of x here, is negative 1/15 times x minus 3 squared times x minus 5 times x plus 1. Again, it's just finding a possible polynomial function that satisfies the properties that are given. And that's a verbal description of the zeros and points that it goes through that you may be asked to find. The other alternative in this section you'll be presented with is finding that equation from a graph, but it'll be extremely similar.